everyone. This is group 19. My name is Manya S Chopra and in my group we have Pritish Saha, Shivam Kumar and Pavan Kumar. Our project is a laser diode security module. These are the group members. This project uses a laser diode module to emit a beam of light. The beam of light is then detected by a photoresistor. If the beam of light is interrupted, the Arduino will trigger an alarm. The alarm will ring for 10 seconds, then stop. The project can be used to protect a variety of objects such as homes, offices and warehouses. It is also a relatively inexpensive project to build, making it a good option for DIY enthusiasts. The research and methodology was very intensive. To gather the necessary materials, we use an Arduino Uno board, laser diode module, photoresistor, buzzer, breadboard, jumper wires and a Bluetooth module. We connected the components to the Arduino using the following connections and uploaded the code to the Arduino. Since we know that the Arduino's basic unit is a microcontroller, it enables it to run a single code throughout its life with only a power supply. These were the technical details. Laser diode module is a module that emits a laser beam. The phototransistor module is a module that detects the presence of a laser beam. The buzzer is the device that produces an audible sound which will trigger the alarm, and the person will get to know that a security breach has occurred through an app which has been installed on his or her phone. The jumper wires are used simply for connections. The breadboard is a prototyping board that allows you to connect components without soldering. And the Bluetooth module was used in order to connect to the device with your mobile phone through the app. This is the code that we used. The challenges and solutions are as follows. The range. Use of the mirrors can be used to reflect the laser beams and increase the range of the security system. This can make it more difficult for an intruder to avoid detection. And the use of the mirrors also does not make the path of the laser beam visible, and so the intruder wouldn't know that there is a security system installed there. But as soon as he tries to take the valuable object, it will trigger an alarm because of the laser security system that we have made. App for alerts. The app can be used to send alerts to your phone when the security system is triggered. This can be helpful if you are not at home or if you are asleep. Sensitivity. We were concerned about the sensitivity of the laser sensor, since it is not possible to use the laser sensor for very huge distances. Hence the use of the mirrors was considered. We use a more sensitive sensor as well. This will make it more likely that the sensor will detect small objects or movements. Applications are wide. Home security. The laser light security system can be used to protect your home from burglars. The system can be installed in any doorway or window, and it will sound an alarm if the laser beam is interrupted. Pet containment. The laser light security system can be used to keep your pets from wandering off. The system can be installed around a yard or garden, and it will sound an alarm if your pet crosses the laser beam. Industrial safety. The laser light security system can be used to protect workers in industrial settings. The system can be installed in areas where there is a risk of accidents, and it will sound an alarm if someone enters the restricted area. Our learnings from the project were numerous. Arduino is a powerful platform for creating DIY projects. It is relatively easy to learn, and there are many resources available online to help you get started. The laser light can be used to create a simple and effective security system. This project demonstrates how you can use a laser diode and an Arduino to create a system that will sound an alarm if the laser beam is interrupted. Adding app and mirrors makes the system more versatile and effective. The app can be used to arm and disarm the system, and the mirrors can be used to extend the range of the laser beam. This makes this device a smart device. This is the photograph of the final system, the demonstration of which we shall show in a few minutes. Pritish worked on the presentation part of the DIY project. He made the presentation that you are seeing right now. Shivam did the coding part in the DIY project. Manya made the circuit assembling of the DIY project, and Pavan was the one who did the designing in the project. We did the mirror placing part and the app making part in the DIY project together, as we all had very limited knowledge in it, so everyone had to contribute, and these two were the most challenging parts of the project as well. Conclusion. The laser light security system is a simple and effective way to protect your home or office. It is easy to set up and use, and it can be customized to your specific needs. The app and mirrors make the security system even more versatile and effective. The app allows you to arm and disarm the system remotely, and the mirrors can be used to extend the range of the laser beam. This project was a great learning experience. We learned how to use Arduino to create a complex project, and we learned about the principles of laser light and security systems. These were the resources that we used. Thank you very much. Now we shall move to the real-life demonstration of our device. To the live demonstration of our laser emitting diode security system. So first I shall explain the components of our device. This is the main setup in which we have the key, which is the valuable object. We have two mirrors placed at an approximately 30-degree angle. Mirror number 1 and mirror number 2. We can also see the laser emitting diode placed over there. Then we have the photoresistor, which is the device sensitive to our laser beam. Inside this black box, we have all our connections made using a breadboard, and as well as all the connections to the buzzer and the Arduino. We have a USB cable connecting it to our power supply, which is the laptop in this case. Now we shall demonstrate the use of our device by making a breach in this security system. As you can see, the buzzer went off and the app got a notification that the security system has been breached. Now I shall explain the code that we have used in our laser diode security module. We have written this code on Arduino IDE, and the code for the Bluetooth module has been written on MIT App Inventor. The pin mode function in this code is used to set the mode of a pin. In this case, the pins for the buzzer and light sensor are set as outputs and inputs respectively. The delay function is used to pause the execution of the code for a specified amount of time. In this case, the delay function is used to wait 100 milliseconds between each time the buzzer sounds. The Bluetooth print function is used to send a value to the Bluetooth device. In this case, the Bluetooth.print function is used to send the value 1 or 2 to the Bluetooth device, depending on whether or not the light sensor is detecting light. So now that we have explained the functions that we are using in our code, I shall go with the explanation of this part of the code, which is our for loop. The first line of the code includes the software serial library. This library allows you to communicate with a Bluetooth device using the Arduino serial part. The next line of the code creates a software serial object called Bluetooth. This object is assigned to pins 9 and 10 on the Arduino. The setup parenthesis function is called once when the Arduino starts up. In this function, the pins for the buzzer and light sensor are set as outputs and inputs respectively. The serial parts are also initialized. The loop function is called repeatedly as long as the Arduino is powered on. In this function, a variable called I is declared. The if statement checks the value of the light sensor. If the light sensor is detecting light, the for loop is executed. The for loop runs 50 times. Inside the for loop, the Bluetooth.print function is used to send the value 1 to the Bluetooth device. The digital write function is used to turn on the buzzer. The delay function is used to wait 100 milliseconds. The digital write function is used to turn off the buzzer. The delay function is used to wait 100 milliseconds. If the light sensor is not detecting light, the else statement is executed. The Bluetooth.print function in this case is used to send the value 2 to the Bluetooth device.